See, this buzzer will produce 4 different sounds with different intervals corresponding to 4 alerts. Like this is the normal, this is warning, this is critical, and this is emergency. But the problem arises when I press the button. This is normal mode, and you can see when I'm pressing the second button, the sound is not changing. Even with the third button, the sound is not changing. So we will rectify this issue in this video. So let's get started. So to start with, let us see how do we connect the components. So this is the push button you can see. So you can see at the back of this push button, it has 2 lines, this one and this one. So this represents that these 2 terminals are connected to each other, and similarly these 2 terminals are connected to each other, but these 2 are separated from each other. Okay. So I'm going to use the input pull-up mode for the push button. So we will require only 2 wires. First wire will be connected to this terminal and other will be connected to this one. So let us place this push button on the breadboard. And you can see I have connected this terminal to the ground rail of the breadboard, and this ground rail of the breadboard will be connected to ground of the Arduino, and the other terminal will be connected to the digital pins on the Arduino. So let us connect all the wires one by one and connect this buzzer. Now let's have a look at the program which is creating the problem. So here we have defined the buzzer, and this is the mode variable which can take 4 values: 1 for normal alert, 2 for warning alert, 3 for critical, and 4 for emergency. And these are the 4 button variables. And in the setup function, all the buttons are defined with the input pull-up mode, and buzzer is defined with the output mode. Now in the loop function, the logic is very obvious. Like if you are pressing the button, then the digital state of button will be low. So for button 1, the mode is 1. For button 2, mode is 2, and likewise mode is equal to 3 and mode is equal to 4. And after setting mode using this if-else condition, we are switching it with different alerts. So for mode 1, we have normal alert. For mode 2, we have warning alert, and similarly critical alert and emergency alert. And these are the functions: normal, warning, critical, and emergency. So in all the functions, we are sending high signal and then the low signal after having some delay. But the main problem is happening due to these delays. Suppose after 800 delay in this normal alert function, you are pressing another button, then obviously your button will be read by the microcontroller. But suppose within this delay, 800 delay, you are pressing the button, then obviously your button will not be read by the microcontroller, because by using delay, the microcontroller is completely gone into the shut-off condition. So it won't be able to handle any other task within this delay duration. So because of that, your button pressed is sometimes read and sometimes not. Now instead of delay function which exhibits blocking behavior, we can use millis function instead, which is non-blocking in nature. So we are defining a new variable buzzer on, which will be acting as a buzzer state. So currently it is set to false. And this is the variable last buzzer time, it is equal to 0. And these are the two arrays, on time and off time. And the main twist comes into the loop function. So all the if-else conditions are same as in the previous case. So let's have a look at this run buzzer function first. So you can see we are using the millis function, which gives you the time since the microcontroller started to run. And we have this variable wait time. If the buzzer is in the on state, then this will be equal to on duration, otherwise it will be equal to off duration. So this wait time will be acting as a delay if you compare this with the previous code. So this function is checking whether enough time has passed in each of the loop iterations or not. So we are taking the time difference between the current time and the last time. If it is greater than this wait time, then we are altering the buzzer state and sending high signal and low signal based on the state of this buzzer on variable. And we are updating this last buzzer time with the current time for next loop iteration. So using this condition, if mode is greater than 0, each of the mode can be called one by one. So you can see the button presses are checked in each of the loop iteration, no matter whether the buzzer is in the on state or is in the off state. The microcontroller is constantly looking for the button presses. So the objective of this tutorial was to explain you the practical difference between using millis function and the delays function, and how can they impact the entire circuit. So if you enjoyed this video, don't forget to subscribe to my channel and share this video. And you can comment all your doubts in the comment section, and let us meet with a new project in another video. And thanks for watching.